Now we're going to look at a different circuit element instead of resistors. We're going to look at light-emitting diodes, or LEDs. These are electroluminescent light sources, which are really easily integrated into circuits. And LEDs are also just becoming generally popular as sources of light for cars or flashlights, etc. But they also make very nice circuit elements. So the circuit symbol you want to look for an LED looks like this. It's an arrow with a line on the right-hand side, and not always, but sometimes to represent that it's not a regular diode, but it's an LED, they'll show little light rays shooting off of it. Now, LEDs, you can't actually put them into the circuit in the wrong way, so you have to be careful that when current is flowing this way, to the right in this diagram, the anode, that is the positive side of the LED, is on the left, and the cathode, or the negative side, is on the right. And the current should be flowing from positive to negative. If you have your LED flipped the other way, then the current is going the wrong way through it. It usually won't kill your LED, but it won't light up at all. So just to see what a real LED looks like, here's a picture of one, not necessarily to scale, they're usually much smaller. The idea here is that just like in the circuit diagram, there is an anode and a cathode. And if you've picked up the LED out of a bin, you can tell the anode side because it's always longer. So this is the longer end, and that is always the anode. So it's not a good idea to try to cut the leads or change the size of the leads on an LED unless you're being careful to make sure to keep the anode longer than the cathode side. Now, if we want to put an LED into a circuit, we have to think about a few things. One is that every LED has a forward voltage called V sub F, or I'll call it V sub F in my lectures, which defines how much the voltage drops as the current passes through the LED. So this doesn't work like Ohm's law with a resistor. Rather, the voltage just drops a set amount, really no matter how much current is going through the LED, or at least that's the ideal model for an LED. The other thing to consider is that each LED has a recommended current rating, and that current rating states how much current can safely go through the LED for a long period without causing the LED to burn out. If you put much more current through it, it will light up more strongly. So the higher the current, the brighter the LED shines, but you don't want to let a lot of current go through the LED because it will burn out. And what happens sometimes if it burns out is that it creates a short in the circuit, and then that circuit element is gone, and that can actually damage other things in your circuit, like your Hapkit board. So you have to find a way to limit this current. And we'll look at how to do that with the circuit now. So this is a very similar circuit to the last one we looked at, in that it has a battery and resistor, but now we've also added an LED. And we have a current that will be flowing through this simple circuit, and I've defined V sub S as the battery power supply, and I've just added a ground here as well. So our goal for specifying an LED circuit like this is to figure out what size resistor you should use to make sure that the circuit behaves properly and you're lighting up your LED without winding up burning it out. So the problem you can state is as follows. Given a desired current I, which you get from your LED current rating, and you have a given supply voltage V sub S, and a forward voltage of the LED, which is specified as V sub F, you want to know what size resistor you should use. And you can solve this problem very easily for a simple circuit like this using two equations. The first equation follows this voltage law for circuits, which says that what I mentioned before, that the voltage drop across a closed path has to sum up to 0. So what that means is the voltage that goes up on the left here, which is V sub S, has to equal the sum of the voltage drops on the right-hand side of this circuit, which in this case is V sub F plus V sub R. And then the second equation you need is as follows. It's simply Ohm's law again, which we looked at earlier when we examined the resistor. And that is that the current going through the resistor is equal to the voltage drop across the resistor divided by the resistance value R. And again, because this is a very simple circuit, there's only one loop, all the current has to be flowing here. And so the current that flows through the resistor is the same current that flows through the diode. So if you specify a current that's going through the resistor, then you know that that same current rating is going to apply to your LED. So when we actually want to do an LED circuit on your Hapkit, let's look at how to connect this up. So over here is a picture of your whole Hapkit board, and then I've zoomed in with this oval on the particular set of pins, which are digital inputs and outputs. And we're going to focus most on this pin 13, because that's actually our very first program is going to light up an LED through this pin. And in software, we will be commanding this pin to go high. And when that happens, this pin 13 will output approximately 5 volts. I say approximately because these systems aren't exact, but it's close enough for our calculation purposes. All right, so what we want to do then, in order to generate light from our LED, is hook up a circuit like this. So we've got our LED over here, and we've got our resistor over here. And you see that I've carefully drawn this circuit and defined the positive, the anode, and negative cathode of the LED such that the current that's flowing through it is going to be going in the right direction to light up the LED. So the current is going to flow this way. And how do I know that that's the direction of current flow? I know because this pin is going to be going to 5 volts, and this pin here is defined as ground, so that's going to be 0 volts. So essentially, this is the same exact circuit that we had on the last slide, only now the power is not coming from a battery, it's actually coming from your Hapkit board. So that's what the circuit looks like in a diagrammatic form. Let's look at what you'll actually be hooking up. So with your Hapkit, you're going to get an LED that looks like this, and you're also going to be getting a resistor, which may or may not have these exact same bands and colors on it. But what you'll want to do is stick the LED anode pin, the positive side, into the D13 pin, and I'll actually show the hole for that pin on the next slide. And then the other end of the LED is going to be connected with an alligator clip or any other simple wire that can close the circuit to one end of the resistor. And then the other end of the resistor gets hooked up to ground. Now, for the kinds of resistors that we're using, it doesn't matter how they're flipped. You could flip them which way is top and which way is bottom, and it wouldn't matter. The current can flow through this resistor either way. So the actual hookups will be done on this side of the board. We will be putting our resistor into the ground pin, and we'll be putting our LED into the 5-volt pin coming out of pin D13. So after you do the next set of quiz questions, you should make this circuit on your Hapkit board in order to be prepared to do the rest of the lecture.